want to finish up this chapter by talking about areas of quadrilaterals. Now, some of the basics, we know, like, for example, the area of a square. Look at this. Here's a square. It's a 2 by 2, and we know how to get the area. You take the length of one side and then the length of the other and multiply them together. And notice we get 1, 2, 3, 4 units here. So it's just 2 squared. So if instead of 2 by 2, if it were s by s, it would be s squared. Now, we extend that a little bit if we're talking about a rectangle. Here's a rectangle, and we know how to get the area of a rectangle as well. So here we've got 2 this way, and then 1, 2, 3, 4, 5, 6. So we got 2, there's 2, 4, 6, 8, 10, 12. We just take the number, the height of the row and multiply by the number of rows, and we get 2 times 1, 2, 3, 4, 5, 6. 2 times 6, and we get 12. Or we could just count these, right? Count these little squares in there. So we know how to find the area of rectangles and the area of squares. Now, and we've got that here. Here's the area of a rectangle. It's just base times height. Now, we want to go to the area of a parallelogram. And I've got a parallelogram down here, okay? And I just want to think about that a minute, because we're going to see the area of that parallelogram is also base times height. And you can see how, by just analyzing this a little bit. Let me change colors here. Notice this little rectangle, this little triangular area over here. Let's suppose that I keep all the area intact, but I'm going to move that over here. I'm going to move it over here. You notice what I've done is I've just moved this triangle, maintaining its area, right over here. Now, when I do that, you notice what I have. I have now a rectangle. I have a rectangle with a base and now a height. So it's like this right here. We had the height and we had the base. So it's still really, it's just like getting the area of a rectangle. Now, if we're talking about a triangle, we can see, okay, a triangle is half of a parallelogram. And you can see that with the little, this little triangle I've drawn here. Now, I've copied it over here. So I've got these 2 triangles, and I want to calculate the area. Well, dig this. If I take this triangle and move it over here, I get a parallelogram. And we've already concluded that the area of the parallelogram is base times height. Well, this triangle, this is like 2 triangles in there, right? I've got this triangle, whoops. I've got this triangle and this triangle. So if I just get the area of this parallelogram, notice here's base, and here's the height. Height is perpendicular. So if I do base times height, that's the area of that whole parallelogram. And then if I take 1/2 base times height. Okay, so that's how we get the area of a triangle. Now remember, there are different ways that you could have the height could appear. Let's look at this triangle here. Obviously here, the height is just this thing. It's perpendicular to one of the sides. Now, you could also have the base completely outside. So, for example, you could have a triangle like this one. And now you have the base here. Okay, so here's the base. And then to get the height, you come over here. Here's the height. And you have to extend this base out a little ways. But the height is what makes it's perpendicular to the base. And it goes up to one of the vertices. Okay, so this is stuff you've seen before. The area of a triangle is 1/2 base times height. Now look at this. Let's just look at this one and see how we would get the area of this thing. And let's suppose this is a parallelogram. Okay, so one of the ways we could do this is we could just take the base times the height, and we get 144. Okay, that's one of the ways we could do it. And notice that because we're viewing this right here as being the height, and this right here as being the base. Now, we don't have to do it that way. We could view this as being the height. Remember, it just makes a perpendicular, and we could view this as being the base. So we could say, okay, I'm going to take 16 times 9. Now, 16 times 9 is also 144. So in both cases, we get the area of this parallelogram. Okay, now let's go on to the area of trapezoids, kite, and rhombus. Okay, now first of all, the area of a trapezoid. The area of a trapezoid is given to us as 1/2 the height times the sum of the bases. Or in other words, what you could do is you could say the height times the average of the bases. So I take the average of the bases. I get base 1 plus base 2. Let's take the average of that and multiply that by the height. That's how we get the area of a trapezoid. Now, what I want to do is I want to explore this idea a little bit with a trapezoid. So let me just draw a trapezoid here. I'm going to just draw a regular trapezoid here, and for convenience sake, I'm going to make this an isosceles trapezoid. Okay, and what I want to do is I want to copy this trapezoid. So copy. And then I want to paste it, and then I'm going to turn it over like this. There. Now, look what I've got. Let's suppose that this is a base. Let's just suppose this is well, I want to be consistent with their notation. This is base 1 and this is base 2 down here. So this is base 2 and this is base 1. Okay, now notice that what we've got now is a parallelogram with this height. Now, if I want to get the formula, if I want to get the area of this parallelogram, what I can do is I can say, okay, it's going to be, let's see if we can remember what the formula for the parallelogram is. It's base times height. Okay, so let's look at this. We've got base, which in this case is B1 plus B2 times the height. See? Because the base is now long there. I mean, it's this whole thing. Well, that gives us the formula for the area of these two trapezoids. We only want half of that. So we took 1/2 the height times the sum of the bases. So that's kind of the way you can look at it to figure out where that formula comes from. Now, we've got the area of a kite, which is 1/2 the product of the diagonals. And you can see this if you draw a kite. Like I've drawn a kite here, and I've got one diagonal is 6 and one diagonal is 4. It looks like two triangles there. The one triangle is 1/2 base times the height, and I double that, right? Because I want this triangle and this triangle. Well, that's going to be 12. Okay? Now, notice that we're saying the area is 1/2 the product of the diagonals, which is 6 times 4. See, this is 2 here, but it's only half of it. And that's 1/2 of 24, which is 12. So the area for the kite is 1/2 D1, 1/2 the product of the diagonals, and that's the same for a rhombus. Okay, so these are some areas, and our objective here is just to work with this and work some problems related to finding area.